Coming to the examples of sensors, I've taken some of the sensors as some examples so that you'll get to know what the sensors actually look like and what we use them for. Coming to the first one, flame sensor. This is what it is and this is how it looks like. So this sensor is actually used to detect the flame in its surroundings. So as soon as it detects some flame, it will give us some data using these pins. All the sensors will have at least 3 pins. 2 pins are used to power them up. That means this is a sensor, and for this, first what we need to do is we need to give the power supply, right? So for the power supply we have positive and negative terminals. Positive is termed as VCC and negative is termed as ground. And the other one, it will give us the output as the data. Okay, so if you have some sensors which give you data in both digital and analog form, you will have 4. So one of which will give you analog data and the other one will give you digital data. But some of the sensors will have only digital data, and some of them will only have analog data, and some of them will have both the datas. So to any of the sensors you will have VCC ground as common, and at least one data pin has to be there for any of the sensors. Correct. So in this we have 3 terminals here. So let me read this out. VCC, ground and D0. D0 is nothing but the digital pin. So you'll get only the digital data out of this. So this is what a flame sensor look like. Coming to second one, which is PIR. PIR means passive infrared. This is also known as motion sensor, and this is what it is. This is used to detect the motion of any person. As soon as a person comes into its surroundings, into its vision range, it will send some signals to the microcontroller board that this has been activated or it has detected something. And the application where we use the PIR is in smart security systems. These can be placed near your CCTV cameras so that as soon as some person gets near to the CC cameras, this will be activated. And coming to LDR, let me show you this. This is LDR. LDR is nothing but light dependent resistor. This has a small thing here which is called light dependent resistor, and using this we can actually calculate the intensity of the light. And coming to DHT22, it is a digital humidity and temperature sensor. That means it is used to detect the humidity and temperature in your surroundings, and this is what it is. This is the DHT sensor. This is used to detect the digital humidity and the temperature in your surroundings, and it will give you the values of humidity and temperature. The application of this sensor is that in smart weather monitoring systems. For example, you are somewhere but not at your home, and you want to monitor the temperature and also the humidity at your home. So you can install this device in your home and it will start giving you the data about the temperature and the humidity in digital form, and you can transmit that data wirelessly to your mobile phone and you can see what is actually happening in your home. And the next one is microphone. Microphone is basically known as sound sensor. This is what it is. This is a microphone that detects sound using this module. Okay, we use this in applications where we want to listen to the noise or the sound or some voice of some specific thing. That is where we use it, the microphone. Coming to the next one, water level depth sensor. This is water level depth sensor. This sensor is basically used to measure the level of the water. This can be used in smart tanks, whereas if you have a water tank at your home and you want to know what is the level of the water in that water tank, then we can use a sensor which is similar to this. It will be placed in your tank and this will give you the readings of what level of water is filled in that tank. And that is where we use it, and this is called water level depth sensor. Coming to the next one, gyroscope. Gyroscope, this is the gyroscopic sensor, which is also called as ADXL345. Gyroscope is nothing but a sensor which is used to detect the tilt of some body. For example, I have my hand here and I've tilted it forward. That means this is the sensor that I use to detect the tilt of my hand. And this is used in an application where you want to control something using some hand gestures or any gestures by just moving something. For example, I have a car and that car has to be controlled using my hand movements. Then I use this sensor to detect my hand movements, and that signals will be transmitted to the car so that it will move accordingly. And this is gyroscopic sensor. Coming to the eighth one, magnetic reed control switch. Magnetic reed control switch acts as a switch but based on the magnetic field around it. This is what it look like. You see here the small thing, right? That is actually a magnetic reed switch. That means as you bring this closer to some magnetic field, there will be some tiny switch kind of things here and that will be attracted to each other. So this will be turned on, and this is used to detect the magnetic field around the body, right? And coming to ninth one, MQ4. We have a sensor here which is MQ4. MQ4, right? So this is actually an air quality sensor. That means you can detect some gases in the air using this sensor. Using this we can basically measure the methane, which is CH4, and also the LPG gases. Where do we use it? Right, in your home we have LPG cylinders, right? So for example, you want to make sure that nothing is being leaked from that LPG gas cylinder. Then you can install this sensor near that cylinder and monitor the data from the air. That is where we use it. And coming to 10th one, MQ135. This is MQ135 sensor which looks similar to MQ4. We have the sensor name here, MQ135. This is also used to measure the quality of air, but instead of measuring CH4 and LPG, it is used to detect CO2 and some other gases, and this works exactly like this. And these both are air quality monitoring systems. Air quality monitoring sensors, which comes under gas and chemical sensors. And coming to this one, pulse sensor. The sensor that we have here, this is a pulse sensor. This is a sensor that is used to detect the heartbeat of a human. You just need to place your hand on this sensor and this will do some calculations and do some adjustments, and it will give you the number of heartbeats you are making per minute. And this is what a pulse sensor is, and we use it in hospitals. Most probably we know what the applications are. Coming to ECG. This is what an ECG sensor look like. ECG means electrocardiogram, right? So using this sensor you can basically measure the heart electrical activity of some person and analyze what is the kind of disease that the person has using the heart signals. Coming to pulse max 30100, it is also a pulse sensor but of different model. This is a pulse sensor which is max 30100. It also behaves the same way that this pulse sensor does, but with higher accuracy. Coming to AC voltage sensor. The sensor I have here with me is AC voltage sensor. That means it is used to measure how much voltage is actually present in some line wire. Correct. We use it in smart energy meters where you want to calculate the AC voltage of some specific mains supply. And we also have AC current sensor. This is the AC current sensor. This is used to measure the current of an alternating current line supply. And this is also used in smart energy meters to calculate the current readings. So this is all about the sensors today. I hope you understood everything that I told you now. If you have any doubts further, comment down below so that I'll reply you, and also comment down the topics that you want me to make videos on so that you will get to learn something new. And also subscribe to this channel if you want to listen more from me, and also like it so that I'll feel motivated to do some more videos. And thank you. This is it for the session. Have a great day. Bye.